Hi everyone, my name's Ben Dodd. I work for a company called Armakuni. We have been using Cloud Foundry for 5 years or so. We have been using Concourse, which is the subject of this talk, for 18 months or so. So what I'm here about tonight is to tell you how to get started with Concourse, but the title of the talk and the initial section is sort of challenging how we think about continuous integration servers, how we think about our own builds and our own Concourse solutions. Hang on. It's going to happen, right? So, I accused you all of having broken builds. This may or may not be true. This is mostly anecdotal, so this is essentially my story of having configured a Jenkins node to deploy a global suite of Cloud Foundries, so to multiple infrastructure providers in multiple regions around the world, and then top of that, deploying a microservices suite of 28 or so applications to each of them, have them all networked together to the point in which they could take 500 donations a second for a sort of a well-known UK charity, and how the time it took, the effort, the problems that we had with that, and how the problems were solved when we moved to Concourse. So I asked myself, and I asked lots of other people who use CI servers, how is your build broken? What are your pain points? So the first obvious one that I got was, we don't have a CI server. So I have a developer friend, works for a well-known American-based searching company, and he's not allowed a CI server because when he deploys it, the assertion is it will instantly become out of date, insecure. So if you want a CI server, you can't. You've got to run it locally. You've got to do whatever else you have to do. Your pipeline is insecure because your software is out of date. There has been security problems. It's not multi-tenant. Users have left the company with a password. It's very hard to change that password. Those sorts of things. Your pipeline is slow, so it's going to break a lot. It takes a long time for you to do a code commit and get some feedback on that. So get it through all the various stages that you need to do. Manual, some not. It is also unreliable or unreproducible. So either when you want your CI server to start at the beginning of a new project, it is difficult to create. You're doing manual things, you're orchestrating, and it's unreproducible in that every time you run your build, it is polluting the next build in the chain. So for us, that was a single vertically scaled Jenkins. It ran a job on that node. The next job came along, ran the same job in the same environment. Some stuff had been installed from the previous build. And if you come up to the point where you have to build a new server, you run the job again, it's like, oh yeah, my build doesn't actually work because at some point along the line, I have gone into that server, installed some stuff, made some manual changes. Your pipeline is a time sink. I think this is true of most projects, but you spend a lot of time configuring it, fixing broken builds, working out why it was broken. Just the time from, oh, my build is broken, the amount of clicking you need to do to get to the error, to work out what has gone wrong so you can do a solution, for us was a long time. And that, for us was Jenkins. So, you click, clickety-clicking, trying to find problems. And also, increasingly, certainly in our world, that the pipeline is not a core deliverable. So for us, if you're doing large amounts of very automated things, if you're automating large platforms and large suites of applications, the configuration of how that is delivered and tested, how you get feedback, how you get that into production quickly is most of the value that you're delivering. And that is increasingly important for us. So what I would like to see for my CI server is that we're treating CI exactly like we treat our software. So we want a development lifecycle. So we want to sit on our computer in our local environments. We want to deliver that pipeline. Develop it locally, work out, test it, almost do test-driven development on how it's going to work before you then commit that code and push it out to the rest of your team. And you also want fast feedback. So you want to You want to make a change to your software, have that very quickly get to the hands of the people that are getting value from what you're doing, and see whether the change you've made was a useful thing to make. And I think that is important when you're operating a CI service too. You want zero downtime. So a lot of what was talked about with Cloud Foundry is that you can push apps, they will scale, it will do blue-green deployments, those sorts of things. And that's important if you've got a team of developers. So if you've got 10, 15, 20 developers, and you're the person that's configuring your CI server, and it goes down for an hour, and that team can become blocked. So you want a process in which CI is always available. You can make changes that will propagate through that system without blocking anyone else. And I guess this is thinking more about sort of 12-factor apps and all those sorts of things, is that you want to be ephemeral. You want it to be able to be destroyed, taken away from you, die, whatever is going to cause that ephemeral behavior. You want to be able to reproduce it exactly as it was without any problems. And you want everything as code. So this is where I personally was before. We were orchestrating with Chef, so that would take a large amount of our times, especially if we wanted to do sort of distributed systems, multi-VMs, a main VM and a load of workers and those sorts of things. That was difficult. And we were also trying to get to the point where everything was as code. So we were using Jenkins Job Builder to declaratively describe what our pipeline was going to be and have that automatically update the pipeline. And we were polluted and inconsistent. So we got that state where we're running on a single VM in a single workspace, lots of times going in, deleting workspace, trying to work out why a build had failed this time but not last time, when seemingly nothing had really changed. It was expensive, it was slow. There was a huge environmental disparity between what we were doing locally and what we could do on CI. So we would merely make changes, we'd have some sort of environment locally, that's all fine, push, and then the build goes red for unknown reasons. And really, there was a poor usability experience. So Jenkins, which is what we were using, the ability to very quickly get to errors, to work out what configuration is, all those sorts of things, is lots of screens, lots of different UIs, lots of inconsistency. That was difficult for us. So I guess, and this is one screen, so when we were migrating away to Concourse from Jenkins, these are the sorts of things that you could potentially miss. And I think a lot of these are Antipatterns. So things like runtime reconfiguration. So with our Jenkins, when you click build, you get the list of variables that you're going to run with that build, and you can change them, and then that build will run. So the next person comes along, looks at that build, go, that build was green, but it actually wasn't, because that person had changed the configuration of the job. I'm not going to talk too much about those. So moving on to Concourse and how we install it. So by far the easiest way of doing that is locally is using Vagrant. I can show you that in a minute, but there's a myriad of other ways of doing that. So Docker Compose for people who are loving the Dockers. It comes as a standalone binary, so you can just have it on a single VM. You can orchestrate it manually or with Chef or however you want to do. But what I spend most of my time doing is using Bosch. And we can talk about why that's a good idea. What's interesting is Bosch was more difficult, is getting even easier, and one of the things that's made it super easy in the last 3 days or so is that Bosch Bootloader has come up with a stable release, and that is a Go tool that allows you to literally type BBL up, and that will configure AWS with all the subnets, VPCs, all that sort of stuff, deploy Bosch, and get you to the point where it's incredibly easy to get a distributed Concourse up and running. Not that way. So, installing locally, all you need to do is these things. This is on the homepage of the Concourse site too. So we're going to do a Concourse Lite and a Vagrant up. We're going to wait 3 minutes or so as it downloads the box. And then we're going to do a fly login. So that is the command line tool written in Go that allows us to communicate with our CI server. And then we're going to set a pipeline. So that's going to take the configuration for our pipeline, deploy it, to Concourse, and then we're going to run it. So then we can, at the point where we can see locally how it's going to look. And this is a very useful tool when we talk about the development lifecycle, because that allows you to develop your pipeline locally in the same way that you would code. So if you've got a running service, you want to make some changes, you want to see how your pipeline's going to work, then you can do all of that locally, and then all you're doing is then changing your API target and then converging against a different concourse. So one of the main drivers of Concourse is that you should be able to learn it in a single sitting. And that's quite a bold claim for something that has been relatively complex. But I think this is genuinely true of Concourse. And one of the good things that it has, it's got some very simple key concepts that you have to get your head around. And then it is just sort of repeating those concepts again and again. So the first one is that it has a concept of a resource. So in this case, this is a Git resource. There is lots of different types of resource. But this one says, I've got a repo called microapp. It's a Git resource. There's its URL. This is what it's going to be called. So simple. So then you get to the point where you want to create a job. So we have a job here. Our pipeline, the name of it is say hello. So in our plan, we're going to get our microapp. And also, we're going to trigger equals true. So this means for a resource, and the resource again can be any type of resource, but every time there is a new version of that resource, it could be an update to S3 or Assembler or PivNet or any of these sorts of things that the build should trigger. So this is, it polling against GitHub, essentially looking for new versions. And then it is going to run this task. So it is going to get that resource. It's going to run it within a Docker image. This one happens to be Ubuntu. And so it's going to fire that up, a new Docker image, so there is zero opportunity to maintain state between builds. You always know that when your task runs, it is in a clean environment that as it was configured, you know exactly what SHA or layer that container was at, and it will run. So this is going to run in the directory microapp, and it's going to run that shell script. So then we get to the point where we want to create a pipeline. So that is going to create a single job that is going to pull a Git resource and run that shell script. So then on the left, we've got that first task, and on the right-hand side, we've got the second one. So the only real difference with this, so we've got trigger true on this one, and then on this side, on the next task, we're saying that we want the resource from our first task, but we want it to have passed that job. So whenever that goes, the left task goes green, it maintains that sense of a last known good version. So it says this SHA of this Git repo is good, and it passes it to this. So this task then is triggered because it gets a new version of that Git resource, and it only triggers when it gets a known good version. So the left task can go red, but it will not trigger the next job down. Hopefully that makes sense. So you get, via the UI, you get this as an expression of that. So we've got our microapp Git resource going into our first job. So this then runs, and then this will go green. So at that point, we've got a new known good version of our Git resource. Good. And then, so when we inspect that job, what we can see is that at the top, our microapp thing, this one here, is that light gray color, and that means there's a new version from Git. It tells us what the commit message and what the SHA is, and then it runs that job, and you can see here, because it was the first time that I ran it, it was checking out the Docker image to run that job. So then our next job triggers, and it says, run this last known good version, and this time it fails. And this is essentially all the UI there is. So there is no opportunity at all to configure Concourse via the UI. And also, it's a very simple UI. So in terms of usability, the time it takes for you to think, my build is broken, to getting to the point where you can see the error is almost always a single click. So, what? Oh, I thought it was a typo giggle. So some of the key commands that we're going to use when we're converging our pipeline. So Flyset Pipeline is the way that we convert that YAML into an actual pipeline. So this is the only way that you have got to configure your pipeline. You create that YAML, you run Flyset Pipeline, and it will give you this diff. So every time you change it, you know exactly what you're going to change. So if I think back to my Jenkins days, if I wanted to do that, that would be run Jenkins Job Builder, go to every single page of my pipeline, which would by the end was 50 or so, and check that the config is as I expect it to be. So this is going to give you this, there's generally a lot more of it, but this is essentially going to say that I've changed this command, is this what I want to do? The next very useful command is fly execute. So what fly execute gives you essentially for free is a pre-commit way of testing your code. So you can say, I have made these changes locally, and I want to push these to my Concourse server and have the tests run. So when I was talking before about like a disparity between my local environment and what happens on CI, what I can say is take this code, run it on CI in exactly the same environment, with the same RAM, with the same networking, with everything that is going to happen on CI, and test that it works. So without blocking my build, without blocking everyone else, without 20 Git commits that say, fix typo, oh, that didn't work, oh, revert, fix typo, which is what I generally have to do, you will get an immediate build fail. So I think that's a very useful tool for you to get incredibly fast feedback. The second incredibly useful tool is Fly Hijack, which is very similar to the CF SSH. So this says, when my build is broken, the container is going to exist for a set period of time on Concourse. I can hijack into that container in exactly the same environment that my test failed in and manually debug it. So I can rerun it. I can do whatever I need to do to debug that. It is not, in olden days world, it was go in, inspect the workspace, try to manually work out what the files were up to, do those sorts of things. Maybe SSH onto the Jenkins box and start poking around. But this is, that you can do this. You can go in and recreate exactly what had just happened. And this is an incredibly fast way of working out what went on with your build. And generally what's incredibly important for a lot of the projects I work on is eventually, and I think inevitably, all the builds slow down. As complexity of your platform and your software solution grows, your build starts to get slower, and maybe you don't notice. And maybe you can't pinpoint which commit made your build go from 1 minute to 12 minutes. So what Concourse is very good at doing, and this is the Concourse's team's own metrics server, but it will stream out metrics not only about the Concourse itself, which I think this one is, but also about all the builds. So you can do pipelines over time of how your builds are performing, and you can pinpoint at the exact point that you started to make your build slow and when you need to start thinking about parallelization and all those sorts of things. And this is, so what happens is that you can get to the point where incredibly complex pipelines, and this is the one that I'm currently working on, which is delivering Cloud Foundry platforms at scale, doing all the tests, configuration, all these sorts of things. And it's doing it 5 times. So you can come up with this sort of complexity, but the process for managing that is incredibly simple. So you can get to the point where your YAML, you're doing some templating to make that easier to manage and those sorts of steps. But if I think back about how I would have to do this manually via Jenkins or via another tool where you haven't got that declarative configuration, you can't make diff changes, you can't revert back to a known good state. I think that would be nearly impossible. So in terms of you getting started, Stark and Wayne, Dr. Nick, has got this incredibly useful resource which step-by-step take you through all the components. It has test, example YAML. You can run a Bosch Lite locally on your machine, a Vagrant instance. So I very much recommend if you're wanting to get started, go for that. And also, in terms of further help, the Concourse team are incredibly useful. So they have a public Slack channel, and lots of people hang out on there. The developers are on there. They're very responsive, who are actually working on Concourse. But there is a good community of other people, and very quickly you will get answers to your problems. And also, because it's open source, the GitHub is there, so you can see what is being worked on. But also, their pivotal tracker is open. So you can see, in terms of if you've got a feature request that you put in, or you're waiting for a specific feature, you can see how that is progressing through the backlog. And also, security-wise, they have a mailing list. So as they're discovering security problems, you can join that mailing list, and they'll send you sort of updates and alerts. Yeah. So after this whole experience, this is where I've ended up. So everything is configurable as code. Everything is committable into Git. Everything is revertible. We've got unpolluted builds because every single build has to be created from scratch. It is scalable. So we are using Bosch. So if we want to scale our platform, we're not vertically scaling a single instance. We're saying change number in Bosch manifest from 2 to 6, and that will give us 6 times more workers. We can parallelize all our tests, and our build may or may not get 6 times faster. And we're getting incredibly fast feedback. So not only in the development cycle of what our CI server is, how it's configured, but also generally builds are faster because we can add complexity which is manageable to our build that will mean our software flows through the whole thing quicker. And it is generally learnt in a single setting, I think. I think most people would get the concepts incredibly quickly. That thing that, the hello world, I defy anyone to do, I think. And also it's particularly good at platforms and software. So it's born out of Pivotal. It's very good at doing Bosch things. It's very good at deploying to Cloud Foundry. And it's inherently good at testing software. Yeah. So yeah, give it a go. I generally think it has improved my professional life immeasurably. Yeah. Thank you.